A car engine is like the beating heart of a vehicle, constantly working and producing energy to move the car forward. When an engine runs, it burns fuel, and that process releases a lot of heat. If that heat is not managed properly, the engine can become too hot and break down completely. That is where the engine cooling system comes in. The main job of a car engine cooling system is to keep the temperature inside the engine at just the right level. It should not be too cold because the engine will not run efficiently, and it should not be too hot because the metal parts could expand, seize, or even melt. The cooling system works to balance this by constantly removing extra heat and keeping the temperature steady as the car runs. Inside the engine, there are hundreds of explosions every minute, as the fuel and air mixture is ignited inside each cylinder. Each explosion creates power and heat. Much of that heat escapes through the exhaust system, but a large amount remains trapped in the engine block and cylinder head. Without a cooling system, this trapped heat would quickly raise the temperature above safe limits. That is why the engine has built-in channels and components to carry away this heat. The system typically uses a special liquid called coolant or antifreeze. This coolant is pumped through the engine and absorbs heat from the metal surfaces. Then it moves away from the engine toward the radiator, where the heat is released into the air. The coolant starts its journey in the radiator, which is a large, thin metal tank located at the front of the car, just behind the grille. The radiator is made up of many small tubes surrounded by thin metal fins. When the car moves, air flows through the grille and over the fins. This airflow helps remove heat from the coolant inside the tubes. The cooled liquid then travels through rubber hoses toward the water pump, which pushes it through the engine block. The water pump is usually powered by a belt connected to the crankshaft, so it keeps running as long as the engine is on. The pump circulates coolant continuously, so heat is always being picked up and carried away. As the coolant flows through the engine, it passes near the cylinders, valves, and combustion chambers. These are the hottest parts of the engine, and that's where most of the heat transfer happens. The metal of the engine block has internal passages called water jackets that surround these areas. When the coolant flows through them, it absorbs the excess heat. After picking up the heat, the coolant leaves the engine through an outlet and heads back toward the radiator to be cooled again. This cycle repeats non-stop while the engine is running, maintaining a stable temperature throughout. The system also has a thermostat, a small but very important device that controls the flow of coolant. The thermostat senses the temperature of the coolant and stays closed when the engine is cold. That allows the engine to warm up quickly to its ideal operating temperature. Once the coolant gets hot enough, the thermostat opens, allowing it to flow through the radiator. This helps the engine run efficiently and prevents both overheating and overcooling. In modern cars, thermostats are designed to open and close automatically depending on real-time temperature changes, keeping everything balanced. Another crucial component is the radiator fan. When a car is moving slowly or stuck in traffic, there may not be enough air passing through the radiator to cool the coolant properly. To fix that, electric fans switch on automatically when the temperature rises above a certain level. These fans pull or push air through the radiator fins, helping to lower the coolant's temperature even when the vehicle is not moving fast. The fan is controlled by a temperature sensor or the car's computer system. Once the temperature drops back to normal, the fan turns off to save energy. The coolant itself plays a vital role. It is not just water, because plain water can freeze in cold weather or boil too quickly in heat. Instead, coolant is a mixture of water and chemicals like ethylene glycol or propylene glycol. These chemicals lower the freezing point and raise the boiling point of the liquid, allowing it to stay in liquid form even in extreme temperatures. Coolant also contains corrosion inhibitors to prevent rust and deposits from forming inside the engine and radiator. Over time, coolant can lose its effectiveness, so it needs to be replaced at regular intervals according to the car manufacturer's recommendations. If the cooling system is not working correctly, several problems can occur. The most dangerous one is engine overheating. When the coolant cannot absorb or release heat efficiently, the engine temperature rises rapidly. You might notice steam coming from under the hood, or the temperature gauge on the dashboard moving into the red zone. Continuing to drive in this condition can cause serious damage, such as a blown head gasket or a cracked engine block. On the other hand, if the thermostat is stuck open or there is not enough coolant, the engine might stay too cold, reducing fuel efficiency and performance. To prevent these issues, car owners need to keep the cooling system in good shape. That means checking the coolant level regularly, inspecting hoses for leaks, and making sure the radiator cap seals properly. The radiator cap is more than just a simple cover, it maintains pressure inside the system. The cooling system is designed to operate under pressure because that raises the boiling point of the coolant, allowing it to handle more heat without evaporating. The cap has a small valve that releases excess pressure safely if it gets too high, preventing damage to the radiator or hoses. When coolant heats up, it expands and needs somewhere to go. That's why modern vehicles have an expansion tank or overflow reservoir. This tank stores the extra coolant and feeds it back into the system once the engine cools down. It keeps the system sealed and prevents air bubbles from forming inside. Air in the cooling system can cause hot spots and reduce the effectiveness of heat transfer, so maintaining a closed loop is important for reliability. Some cars use more advanced cooling designs. For example, high-performance or hybrid vehicles may use electric water pumps that run independently of the engine. This allows better temperature control and can even circulate coolant after the engine is turned off, preventing heat buildup. Some engines also have separate cooling circuits for different parts, like the cylinder head and the turbocharger, each managed by its own sensors and valves. These systems help optimize efficiency and performance while protecting sensitive components from excessive heat. In colder climates, car engines also benefit from heating systems that use the same coolant circuit. The hot coolant passes through a small radiator called a heater core located inside the cabin. Air blown over the heater core warms up and is sent into the car's interior, keeping passengers comfortable during winter. In this way, the cooling system not only protects the engine but also provides heat for the cabin, showing how the same system can serve multiple purposes.